Close your eyes for a moment, not to sleep yet, just to feel where you are, the weight of your body against whatever is holding you, the temperature of the air on your skin, the sounds around you, near or distant, the rhythm of your breathing, slow and steady. You're here, right now, on Earth, a planet spinning through space at over 1,000 miles per hour, orbiting a star at 67,000 miles per hour, though you feel completely still, safe, grounded. But what if I told you something that might change how you think about every single moment of your existence? What if you're not just living on Earth? What if you are the reason Earth exists? What if humans are the experiment? Not a metaphor, not poetry, an actual experiment. One that's been running for billions of years. One that might be observed, measured, recorded by something or someone we've never seen. Tonight, we're going to explore this possibility slowly, gently, without rushing toward answers that might not exist. Because this isn't about finding absolute truth. It's about noticing what happens inside you when you consider the idea. When you let yourself wonder if your life, your struggles, your choices, your very existence might be part of something designed. Welcome. I'm so glad you're here. Let your shoulders drop. Let your jaw soften. There's nowhere else you need to be right now, except right here, listening, drifting, wondering. If these kinds of explorations speak to you, if you find yourself returning to questions about existence and meaning, I'd be honored if you subscribed. It helps others find this space too. But right now, just settle in. Get comfortable. Let the day dissolve. We're going to start with something so obvious you've probably never questioned it. Something so constant, so ordinary, so completely taken for granted that noticing it feels strange. The fact that you can breathe. Right now, without thinking, your lungs are pulling in air. Oxygen molecules are crossing into your bloodstream. Your cells are using that oxygen to create energy. Carbon dioxide is being released, exhaled, returned to the atmosphere. Automatic, essential, effortless. But Earth's atmosphere is not normal. It's rare, statistically improbable. Some would say impossible. Let me show you what I mean. Imagine for a moment that you're standing on Venus. Not that you could survive there, even for an instant. The atmospheric pressure would crush you immediately, 90 times stronger than Earth's, like being 1,000 meters underwater. And the air itself would kill you just as fast. Almost entirely carbon dioxide, toxic, suffocating, laced with clouds of sulfuric acid that never rain down because the surface temperature is hot enough to melt lead. Venus is nearly identical to Earth in size, similar mass, similar composition, roughly the same distance from the Sun, give or take a few million miles. By all accounts, Venus should be Earth's twin. Instead, it's hell. What went wrong there? Or maybe the better question is, what went impossibly right here? Now picture yourself on Mars, the opposite problem. Too far from the Sun. Too cold, the atmosphere so thin it's barely there. You'd suffocate in seconds, and even if you could somehow breathe, the cold would kill you within minutes. Nighttime temperatures plunge to 200 degrees below zero. Mars is a frozen desert, rust-red dust and rocks, dead volcanoes, dried river beds carved into the surface like scars, evidence of water that flowed billions of years ago, but exists now only as ice locked underground. Mars wasn't always dead. Scientists know this with certainty. Ancient Mars had rivers, lakes, possibly oceans covering much of its northern hemisphere, a thicker atmosphere, warmer temperatures, conditions that might have supported life. And then something catastrophic happened. Mars lost its magnetic field. Without that invisible shield protecting it, solar winds stripped away the atmosphere molecule by molecule over millions of years. The water evaporated into space or froze into the ground. The temperature dropped. Life, if it ever began, died. Mars almost succeeded, almost became another Earth, but something failed. Some critical component stopped working, and the entire experiment collapsed. And here we are, on Earth, sitting precisely between these two failures. Not too close to the Sun like Venus, not too far like Mars, just right. They call it the Goldilocks zone, the narrow band around a star where temperatures allow liquid water to exist on a planet's surface. Too close, water boils away into steam. Too far, it freezes into ice. Earth sits in that thin strip of space where water can be liquid, flowing, creating the conditions that life desperately needs. But distance from the Sun is only one variable, only one piece of an impossibly complex puzzle. Earth's atmosphere is 78% nitrogen, 21% oxygen, and trace amounts of other gases including carbon dioxide, argon, water vapor. This exact mixture is breathable for creatures like us. It's also transparent enough to let sunlight through while blocking most harmful ultraviolet radiation. It's thick enough to create pressure that keeps water liquid at the surface, but not so thick it crushes everything beneath its weight. It holds warmth at night through the greenhouse effect, but releases enough heat during the day to prevent runaway warming. How many factors had to align exactly right for this to work? Earth has a magnetic field, generated deep in its core where molten iron flows and rotates. This magnetic field extends far into space, tens of thousands of miles, creating an invisible bubble that deflects charged particles streaming from the Sun. Without this field, those particles would strip away our atmosphere just like they did to Mars. We'd be exposed, vulnerable, dead within geological moments. The magnetic field exists because Earth's core is still hot and liquid after 4.5 billion years. Why? Partly because Earth is precisely the right size, big enough to retain its internal heat, not radiating it away too quickly. Small enough that internal pressure doesn't crush the core into solid metal like it does in larger planets. Then there's the Moon. You've seen it countless times. That pale disk hanging in the sky, sometimes full and bright, sometimes a thin crescent, always there, always watching. But the Moon isn't decoration. It's essential to everything. The Moon stabilizes Earth's axial tilt. Right now, Earth tilts at about 23 degrees relative to its orbital plane. This tilt creates our seasons, the gentle rhythm of summer and winter, spring and fall. Without the Moon's gravitational anchor, Earth would wobble chaotically. The tilt would change dramatically over thousands of years. Seasons would become unpredictable, violent, swinging between extremes. Climate would become unstable. Life, especially complex life, would struggle to adapt to such chaos. The Moon keeps us steady, balanced, predictable. The Moon also creates tides. Twice a day, the oceans rise and fall because of the Moon's gravitational pull on Earth's water. This rhythm has shaped coastal ecosystems for billions of years. Some scientists believe life itself might have emerged in tidal pools, those temporary pockets of water where organic molecules concentrated as water evaporated, then diluted again as tides returned, creating cycles of chemistry that eventually led to self-replicating molecules. And here's what makes this even stranger. The moon is unusually large compared to Earth. Most planets don't have moons this proportionally big. The leading scientific theory for how the moon formed is violent and specific. Early in Earth's history, perhaps 100 million years after the planet formed, something massive collided with it. A Mars-sized object called Theia struck Earth at a precise angle. The impact vaporized both Theia and part of Earth's surface. Debris was thrown into orbit, and over time, that debris coalesced through gravity into the moon. A cosmic accident. A collision that happened to occur at exactly the right angle, with exactly the right energy, to create exactly the stabilizing companion Earth needed for complex life to eventually emerge. One accident. Or maybe not an accident at all. Let's keep pulling at this thread. Water. Earth has oceans. 70% of the surface is covered in liquid water. Water is chemically strange. Most substances contract when they freeze, becoming denser. Water does the opposite. It expands. This is why ice floats. And that floating property is critical. When lakes and oceans freeze, ice forms a protective layer on top, insulating the liquid water below. Fish survive. Ecosystems persist through winter. If ice sank, bodies of water would freeze from the bottom up, killing everything in them. Earth would be dramatically different, possibly lifeless. Water is also one of the best solvents in nature. It dissolves more substances than almost any other liquid, which makes it perfect for biochemistry, for transporting nutrients through cells, for the chemical reactions that life depends on. Where did all this water come from? The leading theory involves comets and asteroids, icy bodies from the outer solar system that bombarded early Earth for millions of years. Each impact delivered water locked in ice. Slowly, impact by impact, the oceans filled. Another series of lucky events. The right number of impacts. Not so many they destroyed the planet, but enough to deliver the water life needs. Then there's the carbon cycle, the system that regulates Earth's temperature over geological time. Carbon dioxide in the atmosphere traps heat, creating a greenhouse effect. Too much CO2 and you get runaway warming like Venus. Too little, and Earth freezes into a snowball. For billions of years, Earth has maintained CO2 levels in a narrow range that keeps temperatures stable. When levels rise, weathering processes and plant growth absorb more. When levels drop, volcanic activity releases more. A self-regulating feedback loop. Most planets don't have this. Earth does. And plate tectonics. Earth's crust is broken into massive pieces that float on the semi-molten mantle below, moving slowly, colliding, subducting, creating mountains and volcanoes and ocean trenches. This process recycles carbon, regulates atmospheric composition, creates diverse environments from deep ocean trenches to high mountain peaks. It also generates Earth's magnetic field by stirring the molten core. Most rocky planets are geologically dead. One solid crust, no movement, no recycling. Earth is alive in a geological sense, constantly reshaping itself. So let's count the variables now. Distance from the sun. Atmospheric composition just right. Magnetic field still active. A stabilizing moon formed by collision. abundant liquid water delivered by impacts, a self-regulating carbon cycle, active plate tectonics recycling materials, each one necessary, each one finely tuned. Remove any single factor, and Earth becomes uninhabitable. What are the odds that all of these aligned by pure chance? Astronomers have found thousands of planets orbiting other stars. Most are hostile. Gas giants larger than Jupiter orbiting closer to their stars than Mercury. Rocky planets tidally locked to dim red dwarf stars, one side eternally scorched, the other frozen. Super-Earths with crushing gravity. Ice worlds in eternal darkness. Finding another Earth, a planet with all the right conditions, seems vanishingly rare. And yet, life on Earth didn't just appear. It appeared quickly. Earth formed about 4.5 billion years ago. For the first several hundred million years, it was molten, constantly bombarded by asteroids, utterly inhospitable. But as soon as conditions stabilized enough, as soon as the surface cooled and liquid water existed, life appeared. The oldest evidence of life, fossilized structures created by microbes, dates back almost 4 billion years. Single-celled organisms, simple but undeniably alive, metabolizing, reproducing, evolving. Life didn't wait. It emerged almost immediately, geologically speaking. That's strange, isn't it? If life were truly a random chemical accident, you'd expect it to take a very long time. Billions of years of molecules randomly bumping into each other until one lucky combination happened to self-replicate. But no, life appeared almost as soon as it possibly could, as if the conditions on Earth weren't just favorable, but designed to produce it. And not just simple life that could evolve. For the next few billion years, those single-celled organisms became more complex. They developed internal structures, nuclei containing DNA. They learned to photosynthesize, using sunlight to create energy and releasing oxygen as waste. That oxygen gradually accumulated in the atmosphere, poisoning most early life but creating opportunities for new forms that could use oxygen for metabolism, unlocking far more energy. Then, around 540 million years ago, something explosive happened. The Cambrian explosion. In a relatively brief period, geologically speaking, nearly all major groups of animals appeared in the fossil record. Eyes evolved. Shells, skeletons, predators and prey. Complex ecosystems suddenly filled the oceans. Why then? Why not earlier or later or not at all? Scientists still debate the triggers. Rising oxygen levels, certainly, but also possibly something environmental, climatic, or even astronomical. It's as if life had been waiting, preparing, and then suddenly accelerated when conditions were exactly right. Fast forward through geological time. Life diversified. Moved onto land, forests grew. Animals adapted to every conceivable environment. But punctuating this history are mass extinctions. 5 major ones. Events where most species died. The largest, the Permian extinction about 250 million years ago, killed over 90% of all species. Volcanic eruptions released massive amounts of CO2. Oceans became acidic and oxygen depleted. The planet nearly became sterile, but life recovered. And after each extinction, life bounced back more diverse than before, as if the extinctions cleared the board for new experiments. The most famous extinction happened 66 million years ago. An asteroid struck Earth near what is now Mexico. The impact released energy equivalent to billions of nuclear weapons. Debris filled the atmosphere, blocking sunlight for years. Temperatures plummeted. Photosynthesis stopped. Food chains collapsed. The dinosaurs, which had ruled for over 150 million years, died. Not all at once, but within a relatively short time, the age of giant reptiles ended. But mammals survived. Small, adaptable, warm-blooded creatures that could endure harsh conditions. And in the absence of dinosaurs, mammals rapidly diversified, filling ecological niches left empty. Primates appeared, then apes. Then, just a few million years ago, something remarkable emerged. Humans, we're incredibly new. If you compressed Earth's entire history into a single year, humans appeared in the last few minutes before midnight on December 31st. A blink, a flash. And yet, in that tiny span, we've done something unprecedented. We've become conscious of our existence. We look at ourselves and ask why we're here. We look at the stars and wonder if anyone else is out there. We create art, music, stories, not because they help us survive, but because they make us feel something deeper than survival. We've developed language complex enough to share abstract ideas across generations. We've built civilizations. We've split atoms and mapped genomes and sent machines beyond our solar system, carrying messages to anyone who might find them. We're not just alive, we're aware that we're alive. And that's extraordinary. Maybe unique in the universe. Maybe not, but certainly rare. So here's the thought that makes you pause. What if all of this, every single factor we just walked through, the perfect distance from the sun, the atmosphere, the magnetic field, the moon, the water, the carbon cycle, the plate tectonics, the rapid emergence of life, the extinctions that cleared evolutionary paths, the final arrival of conscious, questioning beings, what if none of it was accidental? What if Earth is a laboratory, a carefully constructed environment with specific parameters, and humans, conscious humans who ask questions and create meaning, are the result being measured? You might feel something shift inside you when you sit with that idea. Not fear, exactly, more like vertigo. The sensation of standing at the edge of something vast and realizing you can't see the bottom. Let's look at the other worlds in our solar system again, but this time not as random failures. Let's look at them as different experiments, each testing different parameters. Jupiter. Massive beyond comprehension. A gas giant with no solid surface to stand on. Made mostly of hydrogen and helium, the same stuff stars are made of. Jupiter is so large it almost became a star itself. If it had gathered just a bit more mass during the solar system's formation, nuclear fusion might have ignited in its core. But it didn't. Jupiter remained a planet. And because of its size and position, Jupiter acts as a gravitational shepherd for the inner solar system. Its immense gravity deflects comets and asteroids that would otherwise bombard Earth. Some scientists estimate that without Jupiter, Earth would experience far more impacts, possibly preventing complex life from ever gaining a foothold. Coincidence or part of the experimental design? Jupiter has dozens of moons. 4 are large enough to be worlds in their own right. Io, the closest large moon, is the most volcanically active body in the entire solar system. Its surface is constantly resurfaced by eruptions covered in sulfur compounds that give it yellows and reds. Why so much volcanic activity? Because Jupiter's gravity squeezes relentlessly, heating its interior through tidal forces, keeping it molten. Europa is covered in smooth ice, crisscrossed with reddish-brown cracks like veins. But beneath that ice, kept warm by the same tidal heating from Jupiter's gravity, is an ocean of liquid water. Scientists estimate this ocean could be 60 miles deep, twice the volume of all Earth's oceans combined. Dark, cold, but liquid. And where there's liquid water, there might be life. What if Europa represents a different set of experimental parameters? No sunlight reaching the ocean floor, just water, rock, and heat from tidal friction. Can life emerge in total darkness? Can it thrive without photosynthesis, relying instead on chemical energy from hydrothermal vents? We don't know yet, but the possibility is there, waiting. Ganymede, larger than the planet Mercury, has its own magnetic field, something no other moon possesses. It too likely has a subsurface ocean beneath layers of ice and rock. Another hidden sea, another possibility. Saturn's moon Titan is even stranger. Titan has a thick atmosphere, denser than Earth's, shrouding the surface in orange haze. Space probes have landed there and sent back images of a world that looks eerily familiar and utterly alien at the same time. Titan has lakes, rivers, rain, weather, a complete hydrological cycle, but it's far too cold for liquid water. The lakes are liquid methane and ethane, hydrocarbons that would be gases on Earth, but exist as liquids in Titan's frigid environment. Imagine rain falling from a hazy sky, but it's methane rain. Rivers of methane carving channels through icy bedrock made of water frozen as hard as granite. Lakes of liquid natural gas surrounded by hydrocarbon sand. And beneath Titan's surface, scientists believe there's another ocean, this one made of liquid water mixed with ammonia, kept from freezing by heat from Titan's interior. Two separate environments on one moon. Methane chemistry on the surface, water chemistry underground. What if Titan is testing whether life can emerge using completely different solvents, different chemical pathways? Enceladus, a small moon of Saturn, has geysers shooting water vapor and organic molecules into space from cracks at its south pole. Those plumes come from a subsurface ocean, warm and salty, another hidden sea we never expected. Every time we look closer at these moons, we find water. Liquid water hidden beneath ice, kept warm by tidal forces or radioactive decay. Oceans we didn't predict. Environments that might harbor life. What if the solar system is filled with experiments, each one testing different possibilities? And Earth is the one that succeeded in producing something specific. Conscious observers. Beings who can look back and wonder why they exist. Now let's zoom out even further, beyond our solar system, into the galaxy. In recent decades, astronomers have discovered thousands of exoplanets, worlds orbiting other stars. The variety is staggering. Hot Jupiters orbiting so close to their stars that their atmospheres are being stripped away. Super-Earths with crushing gravity. Ice giants, lava worlds, rogue planets drifting through interstellar space with no star at all. A few exoplanets orbit in their star's habitable zone, the region where liquid water might exist. Proxima Centauri b, the closest known exoplanet to Earth, just over 4 light-years away. It's roughly Earth-sized and orbits in the habitable zone of Proxima Centauri, a red dwarf star. But Proxima Centauri is a violent star, prone to massive flares that would bathe the planet in radiation, possibly stripping away any atmosphere. Could life survive there? Maybe life finds a way. Or maybe Proxima b is another failed experiment. TRAPPIST-1, a small, cool star about 40 light-years away, has 7 Earth-sized planets, 3 of them in the habitable zone. Imagine standing on one of those worlds and looking up to see 6 other planets in the sky, some appearing larger than our moon. What would it be like to evolve intelligence there? Would you feel less alone, seeing other worlds so close? Or would it make the silence even heavier, knowing those nearby worlds might be just as lifeless? We've found thousands of planets now, but we haven't found life. Not one confirmed biosignature, not one unambiguous signal. Space remains silent. This is called the Fermi paradox, named after physicist Enrico Fermi, who asked a simple question during lunch one day. Where is everybody? The universe is incomprehensibly vast. Hundreds of billions of galaxies, each containing hundreds of billions of stars. If even a tiny fraction of stars have planets, and a tiny fraction of those planets develop life, and a tiny fraction of those develop intelligence, there should be countless civilizations out there. The galaxy should be teeming with signals, artifacts, evidence of others, but we hear nothing, see nothing. We appear to be alone. Why? Maybe intelligence is far rarer than we imagine. Maybe the path from chemistry to consciousness is so narrow, so dependent on unlikely events that we're the first in our galaxy to reach this point. Someday, millions of years from now, others might follow. But right now, in this moment of cosmic history, we're alone. Or maybe we're not alone, but we're being watched quietly. The Zoo hypothesis suggests that advanced civilizations know we're here but observe without interfering, like scientists studying animals in a nature preserve. You don't walk into the enclosure and introduce yourself. You watch from a distance. You record behavior. You let natural processes unfold. If that's true, then Earth is a protected site, and we're the subjects inside it, unaware that we're being observed. Our every action recorded and analyzed by minds we can't comprehend. There's another possibility, darker but worth considering. Maybe intelligence is common, but it's fragile. Maybe every civilization reaches a critical point where it either transcends its limitations or destroys itself. And maybe most choose, intentionally or not, the latter. We're approaching that point now, aren't we? We have nuclear weapons capable of ending civilization. We're changing our planet's climate faster than ecosystems can adapt. We're developing technologies we don't fully understand or control. Maybe this is part of the test. Can a species survive its own intelligence? Can it cooperate on a global scale despite differences in language, culture, belief? Can it look beyond short-term self-interest toward long-term survival? We don't know if we're passing. We might be failing right now. But let's pull back even further, beyond planets and stars, to the structure of the universe itself. Physics works the same everywhere. The laws governing gravity, electromagnetism, nuclear forces, they're consistent across billions of light years. Light always travels at the same speed. Atoms always behave the same way. You can point a telescope at a galaxy billions of light years away and see the same chemical elements we find on Earth. But why these laws? Why these specific values for fundamental constants? Take gravity. It's extremely weak compared to other forces. If gravity were just slightly stronger, even by 1%, stars would burn thousands of times faster. They'd exhaust their fuel in thousands of years instead of billions. Complex life wouldn't have time to evolve before stars died. If gravity were slightly weaker, stars might never form at all. Gas clouds would never collapse enough to ignite fusion. No stars means no planets, no chemistry, no possibility of life. The strong nuclear force holds protons and neutrons together inside atomic nuclei. If it were a bit weaker, protons and neutrons wouldn't bind. Atoms beyond hydrogen couldn't exist. If it were a bit stronger, hydrogen would fuse too easily. The universe would be nothing but helium and heavier elements. Either way, no chemistry, no life. The electromagnetic force governs how electrons interact with atomic nuclei. Change its strength even slightly, and molecules can't form. No water, no carbon-based chemistry, no you. Every fundamental constant in physics appears fine-tuned to allow complexity to exist. Change any one of them by a tiny amount, and the universe becomes sterile, empty, dead before it truly begins. This is called the fine-tuning problem, and it deeply bothers physicists. Some suggest the multiverse hypothesis. There might be infinite universes, each with different physical constants, and we happen to exist in one where the constants allow observers. We couldn't exist anywhere else, so obviously we find ourselves here. Anthropic reasoning. But doesn't that feel like avoiding the question? If you walked into a room and found a machine perfectly calibrated to sustain your life, would you assume it was luck? Or would you wonder who built it and why? What if the universe itself is designed, not necessarily by a deity, but by something capable of setting initial conditions and letting the experiment run? And if the universe is an experiment, Earth is where something remarkable finally happened. Matter organized itself into patterns complex enough to become aware. You, right now, lying here, breathing, thinking. You are matter that has become conscious of itself. The universe folded in on itself until it could observe its own existence. That's either the most extraordinary accident imaginable, or it's the point, the goal, the reason the experiment was set up in the first place. There's something humbling and elevating about that thought simultaneously. Humbling because you realize how small you are. One person on one planet in one solar system, in one galaxy among trillions. If this is an experiment, you're a single data point among billions. But elevating because you exist at all. Because against impossible odds, the universe created you. And you're not just existing. You're wondering, questioning, creating meaning where none existed before. That's miraculous. Even if you never use that word. That's miraculous. Even if you never use that word. You've probably felt moments in your own life that seemed too perfectly timed to be random. The person who appeared exactly when you needed them. The choice that changed everything. The narrow escape from disaster. If humans are the experiment, those moments might be variables being adjusted. Course corrections. Gentle interventions to keep the experiment viable. Or maybe they're just probability, and you're a pattern-seeking creature desperate to find order in chaos. You'll never know for certain. That uncertainty is part of what makes the question so persistent. Ancient humans looked at the sky and built monuments aligned with stars, Stonehenge, the pyramids of Egypt. Structures requiring sophisticated understanding of astronomy and mathematics. Why? Survival didn't require massive stone circles precisely aligned with solstices, but they built them anyway, as if trying to communicate with something beyond or to mark Earth as a place worth noticing. Every culture has stories of beings descending from the sky, gods, messengers, teachers who gave humans knowledge of agriculture, writing, mathematics. Are these myths? Explanations for what primitive people couldn't understand? Or are they memories? Distorted over millennia, but memories nonetheless of contact, observation, guidance from whoever is running the experiment? We can't know, but the stories persist across cultures that never met each other. That repetition is worth noticing. Here's what keeps me awake sometimes, what makes this question feel urgent rather than abstract. If we are an experiment, we're at a critical juncture. We've developed technology that lets us see the universe as it truly is. Telescopes peer billions of light years into the past. Particle accelerators probe the fundamental structure of matter. We've mapped our own DNA, understood evolution, touched the surface of other worlds with our machines. We've also gained the power to destroy ourselves. Nuclear weapons, climate change, technologies advancing faster than our wisdom. This feels like a test, doesn't it? The final exam? Can this species handle the power it's gained? Can it survive its own intelligence? We're being graded right now. Every choice humanity makes collectively, every decision about how to use knowledge, how to treat the planet, how to treat each other, it's all part of the assessment. And we don't know the criteria. We don't know what passing looks like. But here's what I find strangely comforting. If this is an experiment, then nothing is meaningless. Your struggles have purpose. Your small acts of kindness matter to someone, somewhere. The experiment has a point, even if we can't see it. And if it's not an experiment, if we're truly just chemistry and physics, and staggering in probability, then it's even more remarkable. The universe created you without trying. You're an accident so beautiful and complex that you can contemplate your own existence and wonder if you were meant to be. Either way, you're extraordinary. Take a breath. Feel your body. You're here on Earth, a planet that might be designed or might be luck, but either way is precious beyond measure. And you, human, asking these questions, wondering about your place in everything, you're the most interesting thing this planet has ever produced. Rest with that. Let it settle. We'll go deeper soon, explore what it means to be observed, what it means to matter in an experiment spanning billions of years. But right now, just breathe. You're part of something vast, whether intentional or accidental. Both possibilities are beautiful. You are the experiment, you are the observer. You are the question that might someday become its own answer. Let that thought drift through you. No rush. We have time. When you're ready, we'll continue. But for now, just be here, present, aware. That's enough. That's everything. The silence between stars is not empty. I know that sounds strange. How can silence contain anything? But spend enough time thinking about space, really thinking about it, and you start to notice that emptiness has weight, presence. The distance between galaxies isn't just nothing. It's something we don't have words for yet. Right now, as you lie here, photons from distant stars are passing through your body. Neutrinos from the sun, ghostly particles that barely interact with matter, are streaming through you by the trillions every second. Cosmic rays from supernova that exploded before Earth existed are striking the atmosphere above you. You're not separate from space. You're immersed in it. Part of it. Space is happening through you, constantly, invisibly. And if we're being observed, if humans truly are the experiment, then those observers might exist in that space between things, in dimensions we can't perceive, in forms we wouldn't recognize even if they stood directly in front of us. Let's think carefully about what observation actually means. When you observe something, you change it. This isn't philosophy, it's physics. In quantum mechanics, the act of observation affects the observed system. An electron exists in multiple states simultaneously until you measure it, and then the measurement forces it to choose. The observer participates in reality. If something is watching humanity, we might be changing simply because we're being watched. Our behavior, our choices, our evolution might be different than if we were truly alone. Have you ever changed your behavior because you knew someone was watching? Of course you have, we all do. You walk differently when you know eyes are on you. You speak more carefully. You make different choices. Now scale that up. What if an entire species is being watched? What if we've been observed since the first humans looked at the stars and wondered what they were? Would we know? Would we feel it? Maybe we do feel it. That sense of being watched that humans have reported throughout history. That feeling of presence even in empty rooms. The notion of gods or spirits or something observing from beyond. Maybe that's not superstition. Maybe our brains are picking up something real, something our conscious minds can't articulate, and we interpret it as the supernatural. Or maybe I'm wrong, and it's all just pattern recognition. Brains evolved to detect predators, seeing threats that don't exist. But what if I'm not wrong? Imagine you're the observer, not human, something else entirely. You exist outside our dimensional space, or so far in the future that time itself is a landscape you can traverse. You're watching Earth the way a biologist watches bacteria in a petri dish, except the dish is billions of years old, and the bacteria have become conscious. What would you be looking for? Maybe you're testing consciousness itself. How does matter become aware? At what point does a collection of atoms transition from following physical laws unconsciously to experiencing something, having an inner life, a sense of self? Bacteria don't wonder if they're being watched. Plants don't ask why they exist. Even most animals seem to live entirely in the present, driven by instinct and immediate sensation. But humans do something different. We look inward. We ask questions that have no survival value. Why am I here? What happens after death? Does my life have meaning? Those questions don't help us find food or avoid predators. They don't increase our chances of reproduction, and yet we can't stop asking them. We're driven to seek meaning even when the universe offers no clear answers. Maybe that's what's being measured. Not whether we survive, but whether we wonder. Whether consciousness naturally leads to philosophy, to art, to the creation of meaning in a universe that doesn't provide it. You create meaning every day without realizing it. When you help someone for no personal gain, when you stop to appreciate beauty, when you feel moved by music or stories, none of that is required for survival. It's extra, gratuitous, beautiful precisely because it serves no obvious purpose. Maybe that's what makes us interesting. We're the species that does things for no reason except that they matter to us. Or maybe the experiment is about cooperation. Can conscious beings with individual desires work together for collective benefit? Look at how humans organize: families, tribes, nations. Each level of organization requires sacrifice of individual autonomy for group cohesion. You follow laws even when you could benefit from breaking them. You contribute to society even when you could take without giving back, but we also fight. Wars over resources, territory, ideology, religion. We divide ourselves into groups and treat outsiders as threats. We cooperate beautifully within our groups and terribly across them. If Earth is a laboratory for studying cooperation, the results are mixed. We've built civilizations, yes. We've created art and science and philosophy. But we've also nearly destroyed ourselves multiple times. Right now, humanity faces global challenges that require unprecedented cooperation. Climate change doesn't respect borders. Pandemics spread regardless of nationality. Nuclear weapons threaten everyone equally. Can we cooperate at a species level? Can 7 billion individuals with different languages, cultures, beliefs, and interests work together for collective survival? That's the test happening right now, in real time, and we don't know yet if we'll pass. Maybe the observers are waiting to see what we choose, whether we transcend our tribal instincts or succumb to them. There's another possibility that feels both hopeful and unsettling. Maybe we're not the first attempt. Think about this carefully. The universe is nearly 14 billion years old. Earth is only 4.5 billion years old. That means there were 9 billion years of cosmic history before our planet even formed. 9 billion years for stars to form, live, die, scatter their elements, and create new generations of stars with planetary systems. 9 billion years for other Earths to form around other suns. If life emerges as readily as it did here, if consciousness is a natural outcome of sufficient complexity, then there should have been countless intelligent species before us. Civilizations rising and falling while our solar system was still a cloud of gas and dust. Where are they? Maybe they're the observers. Maybe intelligence, once it reaches a certain level, transcends physical form, becomes something else, something that exists outside time and space as we understand them. Maybe those ancient civilizations learned to manipulate reality itself, to step outside the universe and observe it from without. And maybe they see new experiments, new planets, new species, watching to see if anyone else can reach the same level they did. Earth could be one experiment among millions, scattered across time and space, each one testing slightly different parameters. Or maybe intelligence is common, but long-term survival is rare. Maybe every civilization destroys itself eventually. War, environmental collapse, technology advancing beyond wisdom. If that's true, the experiment isn't about whether intelligence emerges. It's about whether it lasts. And the observers, whoever they are watching to see if we're different. If we can break the pattern, if we can survive ourselves. There's a concept in physics called the Great Filter. It suggests there's some barrier, some challenge that emerging civilizations must overcome to become spacefaring and long-lived. Most fail at this barrier and go extinct. The question that keeps scientists awake is, where's the filter? Behind us or ahead of us? If it's behind us, if the hard part was evolving intelligence in the first place, then we're safe. We've already passed the test. The universe is ours to explore. But if the filter is ahead, if the hard part is surviving once you have technology, then we're approaching it now. Nuclear weapons, climate change, artificial intelligence, biotechnology. Each one carries the potential for catastrophe. Maybe every civilization reaches this point and fails. Maybe the observers have watched it happen 1,000 times before. Different planets, different species, but the same outcome. Intelligence emerges, develops technology, and destroys itself within a few centuries. Maybe they're watching us to see if we're the ones who finally break the pattern. That's a heavy thought, but there's something empowering about it too. If we are being tested, then our choices matter, not just to us, but to something larger. Every decision humanity makes collectively, how we treat the environment, how we use technology, how we resolve conflicts, it's all part of the assessment. And maybe, just maybe, the test isn't about perfection. Maybe it's about effort, about trying despite uncertainty, about reaching towards something better even when you don't know if you'll succeed. Let me tell you something about Earth that still amazes me. We've sent space probes beyond our solar system. Voyager 1 and Voyager 2, launched in the 1970s, are now in interstellar space, farther from Earth than any human-made object has ever traveled. Before they left, scientists attached golden records to each spacecraft, not digital files. Actual phonograph records made of gold-plated copper. On those records are sounds and images from Earth, greetings in dozens of languages, music from different cultures, sounds of nature, thunder, waves, animals, a human heartbeat. There are images too, mathematical definitions, the structure of DNA, pictures of humans, children, families, images of Earth from space showing continents and oceans. Why did we do this? The chances of anyone finding those spacecraft are infinitesimally small. Space is vast beyond comprehension. The Voyagers could drift for billions of years and never encounter another civilization. But we sent the message anyway, because we needed to believe someone might hear it someday. Because the alternative, that we're absolutely alone forever, is too lonely to accept. Those golden records are messages in bottles thrown into an ocean so large we can't see its shores, and they'll outlast our civilization. Billions of years from now, long after the sun has died and Earth is gone, the Voyagers will still be out there, carrying evidence that we existed. That says something about humans, doesn't it? We create meaning even when it seems futile. We reach out even when there's no guarantee of response. Maybe that's what's being measured. Not our intelligence or technology, but our persistence in seeking connection, our refusal to accept isolation. There's a famous equation called the Drake equation, formulated by astronomer Frank Drake. It estimates the number of active, communicative civilizations in our galaxy. You multiply factors together: the rate of star formation, the fraction of stars with planets, the fraction of planets that could support life, and so on. When Drake first calculated it, he got numbers suggesting there should be thousands or millions of civilizations in the galaxy, but we've detected none. The equation predicts abundance, but observation shows silence. Maybe the equation is wrong. Maybe one of the factors is far smaller than we think. Maybe the leap from chemistry to life is vanishingly rare. Or maybe intelligence is common, but technological civilization is fragile, lasting only briefly before extinction. Or maybe the observers enforce silence. Maybe there's a rule: don't contact emerging civilizations. Let them develop naturally. Observe without interference. If that's true, we're in a kind of cosmic quarantine, protected, isolated, allowed to make our own mistakes and discoveries without outside influence. And maybe the quarantine ends when we reach a certain level. Maybe there's a threshold we have to cross before we're allowed to join the larger community of conscious beings. What would that threshold be? Space travel beyond our solar system? Solving our self-destructive tendencies? Achieving some level of wisdom that proves we're ready? We don't know, but maybe the test is to figure it out ourselves, to reach the threshold without being told what it is. Let's think about the universe itself again, about those finely tuned constants we talked about earlier. The speed of light, exactly 299,792,458 meters per second. Why that number? Why not faster or slower? If light traveled faster, the universe would have expanded too quickly after the Big Bang. Matter wouldn't have clumped together to form galaxies and stars. If light traveled slower, the universe might have collapsed back on itself before stars could form. The cosmological constant, the energy density of empty space itself, it's incredibly small, but not zero. If it were larger, the universe would have expanded so rapidly that matter couldn't aggregate. If it were zero or negative, the universe would have collapsed. The ratio of electron mass to proton mass, the strength of the weak nuclear force, the initial density fluctuations in the early universe. Every single parameter sits in a narrow range that allows complexity to exist. Change any one by a tiny amount, and you get a universe that's empty. No stars, no planets, no chemistry, no life, no observers. Some physicists find this so troubling they've proposed the multiverse. Maybe there are infinite universes, each with randomly assigned constants. Most are sterile, but in the rare ones where constants align correctly, observers emerge, and they naturally wonder why their universe is so perfectly tuned. It's called the anthropic principle. We observe a universe compatible with observers because we couldn't exist in any other kind. But here's what bothers me about that explanation. It doesn't answer the question, it just moves it. Why is there a multiverse generating infinite variations? Why not nothing instead? And if you need infinite universes to explain one that works, doesn't that seem like avoiding the possibility that this one was designed? I'm not saying there's a God. I'm saying the universe looks like someone set the initial conditions very, very carefully, and then watched to see what would happen. And we happened. You happened. Think about your own existence for a moment. The specific sperm and egg that created you. If your parents had conceived a day earlier or later, you wouldn't exist. A different person would exist, but not you. Now trace that back. If any of your ancestors, going back thousands of generations, had made different choices, died young, never met their partner, you wouldn't exist. Go back further. If the asteroid that killed the dinosaurs had missed Earth, mammals wouldn't have diversified. Primates wouldn't have evolved. Humans wouldn't exist. If Earth's early atmosphere hadn't accumulated oxygen from photosynthetic bacteria, complex life couldn't have evolved. If our solar system had formed in a different part of the galaxy too close to the center or too far out, conditions might not have supported life. If the Big Bang had been slightly different, if inflation had lasted a microsecond longer or shorter, the universe's structure would be completely different. Every event in cosmic history had to unfold exactly as it did for you to exist. Every single one. The probability of your existence is effectively zero. And yet here you are, and possibility made flesh. If this is an experiment, you're not a random occurrence. You're a specific outcome. the result of 13.8 billion years of cosmic evolution proceeding along one particular path out of infinite possibilities. That makes you rare beyond measure, precious beyond calculation, and maybe that's the point. Maybe the experiment isn't about humanity as a whole. Maybe it's about individuals. Each person a unique combination of matter and experience and consciousness that has never existed before and will never exist again. You're not just data in a cosmic spreadsheet. You're irreplaceable. Let me tell you what happens when you look at Earth from space. Astronauts talk about this. There's an experience called the overview effect. When you see Earth from orbit, hanging in the blackness of space, no borders visible, just clouds and oceans and continents, something shifts inside you. All the divisions we create, countries and religions and political parties, they vanish. You see one planet, one ecosystem, one shared home. Astronauts report feeling overwhelming love for Earth and everyone on it. National identity fades. You don't see America or Russia or China. You see humanity. And you realize how fragile it all is. Earth's atmosphere, the thin blue shell that protects everything alive, looks unbelievably thin from space. Like a soap bubble that could pop any moment. One planet, one species, one experiment. If more humans could see Earth from that perspective, would we make different choices? Would we cooperate more? Fight less? Maybe that's part of the test. Can we achieve the overview effect without leaving the planet? Can we see ourselves as one species sharing one world even while standing on the surface? Some people manage it. They dedicate their lives to causes larger than themselves. Environmental protection, human rights, scientific advancement. They act as if humanity is one family, not competing tribes. But most of us struggle. We're tribal by nature. Evolution programmed us to favor our group and distrust outsiders. It kept us alive for millions of years. But now our tribes are too big, too interconnected, too armed with destructive technology for tribalism to work anymore. We need to evolve again. Not biologically, culturally, psychologically. We need to expand our circle of empathy to include everyone. That might be the test. Can consciousness transcend its evolutionary programming? Can intelligence override instinct? We're trying, slowly, imperfectly, but there's progress. 1,000 years ago, most humans never traveled more than a few miles from where they were born. Strangers were threats. Different languages, different gods, different ways of living, all reasons for conflict. Now we're globally connected. You can talk to someone on the other side of the planet instantly. You can see how they live, hear their stories, realize they want the same things you do. Safety, comfort, love, meaning. That connectivity is new. Historically speaking, it just happened, and we're still learning how to handle it. Maybe the observers are watching to see if connectivity leads to empathy or to greater conflict. Whether global awareness brings us together or tears us apart. Right now, it's doing both. You, personally, are part of this test. Every interaction you have with another person, every choice you make about how to treat someone different from you, it contributes to the outcome. If we're being graded, your choices matter. Not because you're special in a way others aren't, but because you're part of the collective result. We all are. There's something both terrifying and comforting about that. Terrifying because it means responsibility. Your actions ripple outward in ways you can't predict or control. But comforting because it means you're not powerless. One person can't change everything, but one person can change something. And if enough individuals change small things, the collective outcome shifts. Maybe that's how we pass the test. Not through grand gestures or heroic acts, but through countless small choices made by billions of people. Kindness instead of cruelty, cooperation instead of competition, curiosity instead of fear. Aggregated over time, those choices could determine whether humanity survives or fails. Let's talk about time itself for a moment. You experience time as linear. Past, present, future. Memories behind you, possibilities ahead. Time flows like a river carrying you forward. But physics suggests time might not work that way. Einstein's relativity shows that time is relative, flowing at different rates depending on gravity and velocity. What's simultaneous for you might not be simultaneous for someone moving at a different speed. And some interpretations of quantum mechanics suggest that the future might influence the past, that causality might flow in both directions. If that's true, if time is more flexible than we think, then maybe the observers exist outside time altogether. They might see all of Earth's history simultaneously, the way you might see an entire movie laid out frame by frame. From that perspective, you've already made every choice you'll ever make. Your life, from birth to death, already exists as a complete structure in space-time. But you don't experience it that way. You experience the unfolding, moment by moment, uncertain about what comes next. That uncertainty might be essential. If you knew the future, would you make the same choices? If you knew outcomes in advance, could free will exist? Maybe the experiment requires uncertainty. Observers watching from outside time, but subjects experiencing time linearly, making choices without knowing how they'll turn out. Your uncertainty is part of the design, and maybe that's okay. Maybe not knowing is what makes choices meaningful. If you knew you'd succeed, there'd be no courage in trying. If you knew you'd fail, there'd be no hope. Uncertainty creates space for both courage and hope. Those might be uniquely human qualities. Bacteria don't hope. They react to stimuli automatically. Even complex animals seem to live mostly in the present. But humans hope. We imagine better futures that don't exist yet, and then we work to create them despite uncertainty. That's remarkable. That might be what makes us worth studying. I want to tell you about one more thing before we close. Music. Music has no survival value. It doesn't help you find food or avoid predators or reproduce more successfully. And yet every human culture creates music. Always has, probably always will. Why? What evolutionary advantage does music provide? None, at least not obviously. Music is pure meaning-making. We take sound waves, patterns of vibration in air, and assign them emotional significance. A certain sequence of notes makes us sad. Another makes us joyful. Another fills us with awe or longing or peace. We create and consume music compulsively, spending enormous time and resources on something that provides no material benefit. Art is the same. Stories, paintings, dance, poetry. None of it necessary for survival. All of it central to being human. Maybe that's what's being measured. Not our ability to survive, but our ability to create meaning and beauty for its own sake. You're doing that right now in small ways. When you appreciate a sunset, when you're moved by a song, when you feel connected to another person. Those moments don't advance your survival, but they make you human. And maybe that's the point of the experiment, to see if matter, organized sufficiently, spontaneously creates meaning and beauty. The universe, through us, appreciating itself. You are the universe looking at itself and deciding it's beautiful. That's extraordinary, whether anyone is watching or not. Feel yourself drifting now. Your breathing slow and deep, your body heavy and still. We've traveled far tonight. From Earth's perfect conditions to failed experiments on other planets. From the silence of space to the fine-tuning of physical constants. From the question of observation to the meaning of consciousness. And through it all, one truth remains: you exist. Against impossible odds, you're here. If humans are the experiment, you're part of the result. Your consciousness, your choices, your ability to wonder and create and love, all of it matters. Not because you have to be perfect, not because you have to save the world single-handedly, but because you're part of something vast and ongoing, a cosmic story billions of years in the making. And the story isn't finished. The experiment continues. Tomorrow you'll wake and make more choices, small ones, mostly. How you treat the people around you, whether you create or destroy, whether you reach toward connection or retreat into isolation. Those choices ripple outward. They contribute to the collective result. We're all being tested together. And maybe the test isn't about perfection. Maybe it's about trying, about reaching toward something better, even when you're not sure you'll succeed. That's courage, that's hope. That's what might make us worth observing. Rest now. Let these thoughts settle like snow, quiet and soft. You don't need to solve everything tonight. You don't need to understand the purpose of existence or determine if we're passing the test. You just need to rest. To be here, to exist as fully as you can, because existence itself might be the answer. Consciousness emerging from matter, the universe waking up to itself through you. That's beautiful. That's enough. Sleep now. Dream of stars and distant worlds. Dream of observers watching with curiosity and hope. Dream of humanity passing the test, not through perfection, but through persistence. Or dream of nothing at all, empty, peaceful darkness. Either way, rest completely. You've earned it. You're part of something vast, whether designed or accidental. Both possibilities are miraculous. You are the experiment. You are the question. And maybe in living fully and wondering deeply, you're also the answer. Good night, beautiful experiment. Good night, impossible, being made of stardust and consciousness. The observers, if they exist, are watching you with wonder, because you're rare, precious, worth every billion years it took to create you. Sleep deeply. Rest completely. Tomorrow the experiment continues, and you'll be part of it. But tonight, just this moment, let everything else fall away. You're here. You're conscious. You're asking questions that matter. That's extraordinary. That's enough. Good night.